In this video we are going to derive the quadratic formula. So we are given with the quadratic equation, that is ax square plus bx plus c. So here we are going to use the completing the square technique. So I'll just give you a brief idea on what the completing of square technique is all about. So basically we are given with a square and 2ab. So what needs to be added in order to have the expression as a whole square? For example, if I want the expression a square plus 2ab as an expression of the whole square, all I have to do is add b square, so that I'll be getting a plus b the whole square, right? So but in mathematics we can't simply add an expression just like that. If an expression has to be added, it also has to be subtracted. So when I add b square, I am also subtracting b square, so that the meaning of the expression does not change. But the whole idea is to introduce this b square in order to have the expression completed as a whole square, which is a plus b the whole square minus b square. So this is completing the square technique. And now the question which we have to ask ourselves, how we are going to form this b square? So we are getting this b square with the help of this 2ab expression. So when I isolate the 2ab expression alone, I am having b over here. And how I am getting this b? Simply by dividing it by 2 and removing this a. So when I divide 2ab expression with 2a, I am getting b. So I can write the whole method as an expression like coefficient of x divided by 2 the whole square. So the coefficient of x meaning I am basically removing this a. Here I have removed this a by dividing it by a, but when I write coefficient of x, it means this x can be easily removed. Instead of dividing the expression by x, I can easily remove the x by writing coefficient of x. And now I am dividing it by 2. The reason is simple, because we have divided 2 over here. So coefficient of x divided by 2. And what is the need of this particular square? Because I should add and subtract b square over here. So we shall use this formula in order to achieve the result easily in a quicker way, which is coefficient of x divided by 2 the whole square. So we are also, here we are having a square. Here we should be having ax the whole square, but that is not the case over here. So what I can actually do is, I can remove this a. You can either write a as root over ax the whole square, but that is going to make the expression more complicated. So what we are going to do is, I am going to divide it by a. So when I do that, I am getting x square plus b by ax plus c by a is equal to 0. And I am having x square plus b by ax. I am going to bring the c by a to the other side, which will give me minus c by a. Now we are going to complete the square on your left hand side. So and how will I do that? I have already given you a formula, right? What is the formula? Coefficient of x divided by 2 the whole square, which should be coefficient of x is b by a, divided by 2 would give me b by 2a, and the whole square would give me b square by 4a square. So x square by b by ax plus b square by 4a square, and I am also adding the same b square by 4a square on the right hand side, so that the expression's value does not change. Now it is playing the role of a square, and this one is playing the role of 2ab, and this one is playing the role of b square. I can write it as a plus b the whole square. So I can I can put it up like a plus b. And how will I get b? By taking square root. So b by 2a the whole square is equal to, we can take LCM for the denominator. I can make the denominator common, which would give me 4a square. So 4a square is practically, I should multiply 4a on the numerator as well as on the denominator. So it would give me 4ac minus 4ac plus b square. Now what I can do is, I can take square root on both sides. So x by x plus b by 2a is equal to root over b square minus 4ac, and this one's root would be give me 2a, and I can also write plus or minus, so which would give me x is equal to minus b by 2a plus or minus root over b square minus 4ac divided by 2a. So this is my quadratic formula, minus b plus or minus root over b square minus 4ac divided by 2a, where the b square minus 4ac can be called as the discriminant. So x is equal to minus b plus or minus root over delta by 2a, and the values of delta will determine whether the roots are real or imaginary. So quadratic formula has been derived. Thank you.